Hey guys, Brian here in Bailey. I was able to negotiate a spot on the couch. And we've got a non-standard piece here today. We've got some viewer mail. So this comes from fellow YouTuber James Kilroy there in Vicksburg, Mississippi. I imagine if you watch my channel, you're probably familiar with his as well. If not, you should go check it out. He's been kind of slipping here lately. He hasn't put a lot of videos out, but yeah, life gets busy and we don't get things done the way we want sometimes. So let's check it out and see what we got here. Got some number 37 drills. So, a little smaller stuff than I normally fool with, but you never know when I run across something like that. Maybe make some camera mounts or something. Or maybe they're for this. This was a dividing plate that he made for his K&T dividing head on the rapid prototyping printer. So this is some kind of thermoplastic, I guess is what those are. Korean 7/32, 1.25" arbor, brand new. A very narrow side mill, maybe you could use as a key slot cutter, or a wide slitting saw. Probably not really intended for that, but it worked. So let's see what James says here. Closed dividing head, a while back 3D printer. Offer to check on your comparator. I can take you up on that offer if it still stands. If this works out, see a printed plate for one-off part would be very cost effective. Let me know what you find. Take the time to check it out. So that's what we're going to do. We're going to go over the comparator and see if it can see what you got here. Also got some congratulations on the impressive work on the barn. And keep it up. Well, not going to quit at this point. Too far in, so we got to keep going. So, looking at this dividing head plate, the first things I notice are these holes aren't perfect. Particularly on this, I'm going to say this was the back side, the side that started against the plate. Some more so than others. They're not really round holes, so I can see that maybe being a problem. Same thing on these holes. But the first thing I'm going to do is we'll throw it in the comparator and take a look at it as is. Then maybe I'll take a drill of the proper size and clean them up and see if the positional accuracy was enough to make it work, even though the holes maybe didn't come out perfect in this. As long as they're in the right place, it would still give you something pretty quick to go by. So let's see what it looks like. I'm sure y'all won't be able to see these numbers on here, but you can see the shape. But anyway, this is one of the main bolt holes, and you can see it goes from about 150 each way this way to like 145 probably that way. It's kind of an ovalish hole. It's close to 300 thousandths, looks like. Let's check out here, see. Yep, 300 and a half. Yeah, 283 the other way. There's another hole. About saying if we line up 150, it's probably closer to being on size. It's not oval, but it's got these big hunks sticking in here. This is the third one. About the same. It's close to on size. It's kind of caved in over here on this side. This side's pretty good. Matches the arc. So if there's one big chunk in there. And this plate's really too big for me to go from the center out like what I'd like for this magnification. So I don't know if I can catch two holes. Let's just look at a hole. It's roughly 120 diameter, so I'm assuming that they're supposed to be 1/8 inch holes. Again, the hole's not clean, so that one there's a little better. It's kind of blowed out that side though. It's a pretty good looking hole there. Yeah, that's a pretty nice hole, actually, looks like. And there's not too good. So looks like there's roughly a 10 thousandths error, at least, associated with these holes. And I can't get them both on the scope at the same time. The max I've got on these micrometers is 1 inch, so can't screw out far enough to measure the hole position. The fail there, I guess, don't have a low enough magnification on that optical comparator to get out far enough to measure how far apart these holes are. They're more than 1 inch, which is the furthest the scales will move on that, so couldn't do it that way either. So we're down to the same kind of methods that most people would have in their shop for inspecting this. And what I got is 2 1/8 inch drill bits. And what I notice is going that hole kind of starts in but won't go through. Won't even start in that one. Kind of starts in that one. One. So out of this outer ring of holes, only one of them will the bit fit in as it is. So let's try and so let's clean that up. Now just a couple twists of drill. There you go. Let's do this one this way. Not super tight holes, but probably functional that way. See what we get. There's got a little rock, so it'll be tricky. To not squeeze it in. Looks like I get 1/526 on the holes that are good and tight. So I'll measure these, see if they're 123.5. Also 123.5. Measuring this inner bore anywhere from 1.714 to 1.735, so got essentially 20 thousandths. That's back to that Looks like there's a 10 thousandths side error on this printed material roughly. So I would say that you can expect the holes to be no better than within 10 thousandths. And that's really a side, so actually there's probably a total of 20 thousandths on the holes. However, once I run the drill bits through them, did clean them up, they look a whole lot better. Application being dividing plate, not a bearing, Class A bearing fit. I would say this would work for locating a pin. They're not sloppy enough to make any difference as far as that goes, I don't think. Pretty loose. See that? But as far as positionally, if I hold that straight and move it, it's got enough grip that it doesn't really walk around. Alright, so these are our spacings averaged over the pins to try and make the best guess as to where the hole would be if you actually stuck a pin through it on a dividing head where this is intended to be used. And you can see we've got anywhere from 522 to 534. So we've got that 10 thousandths, well plus actually that would be 12 there, error. So these numbers are including the drill bit diameter, so that's subtracted out for the actual spacing. But for now, I'm gonna go get a piece of paper and we'll figure out what these numbers should be, and then we'll see what the error is in this part. Alright, so let's see about taking a look at the math here. I went in there and worked it out in order to find what the angle is here. You've got a triangle right here. So it's a 2.5 inch radius out to the hole. So we've got 2.5, and then the worst hole measured 1.522. Take out the drill bit diameter is 1.399 separation. Divided by 2 because that's the square, and you got 6995. So sine of the angle is equal to 6995 over 2.5, which is 16.25 degrees. So, but then it's times 2 because we've only done one right triangle, so 32.496 degrees. And the worst over was 7055, which is 32.783 degrees. So 0.287 degrees was the maximum error between the two, but the actual divisions, 360 divided by 11 is 32.727. So the worst error from what is supposed to be correct was 0.231 degrees. Now on the K&T dividing head, I believe it's 5 rotations to 1. So that's going to take that error down to 0.0462 degrees on the actual output side. So take the sine of that times a 5 inch radius for a 10 inch gear, assuming that's what the pacemaker's got, and you've got a 0.004 error on the tooth. That's the worst with this. So it's probably within an acceptable tolerance for that size gear on that machine, It's not amazing, but it's not bad either. So, I mean, it's been running with a whole entire tooth missing, so it's a lot better than that anyway. So that's what I found out on this. I said it's certainly not, it's not precision, but it's not bad either, especially not for the time involved. I don't know how long it took to print this, but probably less time than it would take to set it up and drill it all out. Even if you did it on a rotary table and drilled them. And even then, I mean, with a drill bit, legitimately, if you just drilled these, you're probably going to be 5/1000ths error on the hole. So you're probably only twice as bad as drilling this plate as far as accuracy wise. So for a quick get her done, I think this would be alright. If you want something precision, then you need to go to either make it, drill it, or if you want to go even higher than that, then you know you're going to have to bore the holes in it. So, or use jig guides when you drill it, center drill, spot drill. Lots of things you can do to make your holes better positioned, but not bad. That's your 4/1000ths error on 10-inch gear. The smaller the gear, the less that error would be, of course. So, you know, a 5-inch gear, you'd be off 2/1000ths. But that's what I found out. Alright, so that's that. The K&T dividing plate has been inspected to the best of my capabilities here. It would have been nice to do this entirely on the optical comparator, but I guess I need to find a lower power lens for it so that I can do bigger components. That's just too big a range. An inch is the most I can cover. When it gets beyond that, it's off the scales and off the chart. So hadn't really realized that until the other day when I was messing with that screw. But it was interesting to see what the holes look like on there blown out, give you an idea. So, but that's what we found out. Was probably half as good as drilling this from scratch, accuracy wise, but quite possibly still acceptable. You know, if this was a drilled plate and it was 2/1000ths error, I would say it'd be totally acceptable on a 10-inch gear. 4/1000ths, depending on the class of fit, it's probably, I don't know, it may be too much. But what you could do, since I've marked all these on here, if I send this back to James, I don't know if he wants it back or not, but you could use the ones that are closest to being the right holes spacing, because he doesn't have to do every tooth. You know, I think he's only got one tooth or maybe two teeth missing. So you can catch it like right here, 1529, 531, 533, and use these three holes to do your three teeth in a line there, and your error would be very insignificant if you use those holes. You know, it's mainly these two here that are far apart, where this one's closer to this hole and that one's over, because that's, you can see by the numbers, this hole here is not positioned very good. But if you stayed away from that hole, like I said, you'd be half the error on this plate, and that'd be as good as a drilled plate. So I guess the lesson takeaway from this is if you inspect what you're using and you know what you've got, you can make this work. So it's a viable alternative. Printing this up and throw it on there and knock it out. Just gotta be careful with it. So thanks for watching and thanks for subscribing. Hope I didn't bore you to death with the mathematics on here, but that's what it takes. So I'll catch y'all later.